Good morning all. So in the previous class we have gone through the single phase AC system with a pure resistor. So what is the behavior of the resistor if it is connected to a single phase AC system? But in this class today we are going to deal the single phase AC system with which is connected to the pure inductor. So come to this diagram here. So let us consider the single phase this AC system here, which is has a pure inductor. So this is my inductor and which is connected to a single phase AC system, and this is V is equal to Bm sin omega t, and due to this voltage the current produced in this circuit, you can say this is the I is the current is produced, and this is the inductance L. It is a inductive coil, you can say. So whenever the voltage is applied to this AC circuit, whenever this voltage is applied to the AC circuit, so it is going to produce the current, and if this current flows through the inductive coil or it is flows through the inductor, then it is going to produce the flux. And this flux linkage with link with the inductive coil inductive coil. So therefore it is going to produce or it is going to induce the EMF. So due to this flux linkage in the inductive coil, it is going to induce the self EMF. So if you write the mathematical expression for what is the self EMF here, the self EMF E is equal to, you can write, minus L di by dt. So this is the expression for induced EMF in the coil. So what is this phenomena? Why whenever the flux is linking with the inductive coil, then the EMF induced, so that phenomenon is called a Faraday's law of electromagnetic induction. So what is that Faraday's law? We will going to see a detail when we are going to study the electrical machines. So here, as of now, you just remember the EMF induced in this inductive coil is equal to minus L di by dt. Why? What is mean by this negative polarity here? So this polarity is given here. So according to the Lenz law. So what is the Lenz law here? Is the Lenz law always opposes the cause. So that is the Lenz law. It will oppose the cause. So suppose here in this electrical network, my induced EMF E is produced because of the applied voltage. So this is the induced EMF will opposes this cause. So that is the meaning of Lenz law. So due to this voltage, this EMF is induced. So because of that reason, this induced EMF try to opposes my applied voltage, or it induced EMF opposing the cause. What is the cause here? It is nothing but applied voltage, which is responsible to producing the induced EMF. So that is the Lenz law here. So this is what the EMF has induced in this coil, and this is the voltage you can talk. If it is, this is the supply voltage, you can talk. Now if you apply a KVL in this loop, then you can write here, this is you can simply write here. So this is nothing but V plus equal to 0, I can write, or I can write V is equal to minus E, where instead of this one EMF I can write minus L di by dt. So this I can write. So further if you simplify this, the V is equal to, it will come L di by so dt. So this is the one kind of expression you can carry out whenever if it is required. So if you further simplify this one, so further simplify this equation, I want to write what is di. So di I can write V by L into dt. So this is also one kind of equation I am writing. And here di I also I can write, instead of this voltage, this voltage value, I can write this expression. So I can write this expression. Therefore the resultant, the expression you will get is Vm sin omega t and dt. So this is what we are getting. And if you remove this differentiation term here and you want to find what is the total current, so obviously it is coming as a integration and Vm by L sin omega t into dt into dt. So this is the current equation or current expression you are getting. If you further simplify this equation here, so I can write here, I is equal to Vm by L integration of sin omega t, I can write minus cos omega t by omega into do the simplification of this one. So you can say that this is Vm by WL. So instead of minus cos omega t, I can convert that into sin omega t by taking the sin omega t minus pi by 2. So this is also trigonometrical formula I am utilizing here, applying here to convert this term into minus cos omega t into sin omega t minus pi by 2. So this is the expression you are getting. So this is the current expression you are getting. You can take, this is the equation 2, and what is the instantaneous voltage equation we know? This is the instantaneous equation, isn't it, this one? So I can write this one here once again. So this is my Vm sin omega t, Vm sin omega t. So these are the two equations I come to know, isn't it? Now again come here. So this I also again I can write as some Im sin omega t minus pi by 2 where my Im is here Vm by WL. What is this WL term is called? This is nothing but W is 2 pi F and L. So this is what it is also called a inductive reactance. Or it is named as XL. X suffix L is called inductive reactance. You know, L means inductor, F is frequency, and 2 pi. So WL is called a inductive reactance and it is named as XL. So that is the name has been given. So XL is called a inductive reactance. It is a inductive reactance WL or 2 pi FL. It is in units is ohm. So this is the reactance in units is ohm. So this is reactance is nothing but the inductor, the resistant property of the inductor is called a inductive reactance. So resistance means obviously you can measure in ohms. Similarly, the reactance is also a resistance property of the inductor. So this is also measures in ohm. The unit is ohm. So this is the concept, you need to understand what is meant by the inductive reactance. So if you want to draw the phasor diagram here, the phasor diagrams here, so I want to draw what could be the phasor diagrams here, phasor diagram, so that I can draw here. So from the equation 1 and equation 2, if you observe from the equation 1 and equation 2, these are the two, I can say these are the two instantaneous current and voltage. If you draw these two equation waveforms here, so my waveform is coming like this. I can draw, first I am trying to draw the instantaneous waveforms, after that I will go for the phasor diagram. So I know this is my V. If you take V is equal to Vm sin omega t, so obviously this is going to start from the origin. This is nothing but my V is Vm sin omega t, and my current, when you talk about the current, here current is sin omega t minus pi by 2. It means if you say it is a 0 and this is a pi by 2 and this is the pi angle and this is a 3 pi by 2 and this is the 2 pi angle, if you say, then my current will start from after a 90 degrees. Omega t minus pi by 2 means my current is instantaneous current is a sine wave, but which is start from a late to the 90 degrees. So from this 90 degrees it will going to start and it is going to start and it is has going like this. So this is the meaning of the equation. So here omega t minus pi by 2, it means my current lags 90 degrees with respect to the voltage. My voltage waveform has led the current waveform by a 90 degrees. So that is what you need to understand here. Now see, so my voltage waveform has leading my current waveform by a 90 degrees. So that is the meaning here, you need to understand. So after this, what can I can summarize some points here. So I can say my in case of this inductive reactance, if it is connected to the AC system, then this current lags voltage by 90 degrees, or voltage leads current by 90 degrees. So these two statement are same meaning. It means whenever the my AC supply is given to pure inductor, current lags voltage by a 90 degrees. So this is what the instantaneous terminology if you talk. So similarly, if you draw the phasor diagram, of this AC quantities, then if I am take my voltage, this is the VRMS voltage, is the phasor voltage is a reference here. I am taking this is a reference, or so it is a reference, so it is the angle of 0 degrees, V at an angle of 0 degrees, V is a reference, but my current is lags 90 degrees. So that is the meaning here. So I want to write, so I can show here my current would be coming in this direction, and this current I is lags by a 90 degrees. If you see here, this is a 90 degrees, because always my vectors will rotates in anti-clockwise direction. Always my rotors rotates in anti-clockwise direction. So therefore, if you say this voltage, if you take as a reference quantity, then my vector is rotating in this direction, anti-clockwise direction. So always my vector is lagging with an angle of 90 degrees with respect to this voltage. So that is the that is the concept we need to understand here. So this is my reference angle, and if you take the reference vector, then if you want to represent the voltage lags, current lags voltage by 90 degrees, then this is what the current lagging voltage by 90 degrees. So that is what. So always your vectors rotates in anti-clockwise direction or counterclockwise direction. So with respect to this rotation, if you see here, so this is lagging by 90 degrees. So that is the meaning you need to understand here. Now come to the part is I want to calculate the instantaneous power. Instantaneous power. I want to calculate what could be my instantaneous power. So that is I need to understand here. So as we know that, so this is my instantaneous voltage and this is my instantaneous current. If you see, my instantaneous power is nothing but the product of instantaneous current and product of instantaneous current and voltage. So this is we know how to multiply that part. Now if you come here and if you do the product between the voltage waveform and the voltage waveform and your current waveform, then obviously if any quantity is coming negative, this positive into the negative, obviously this is going to gives us a negative power. And if you multiply these two, these are the two positive, this is positive and this is positive, this is positive and this is positive, and up to this point this is both are positive. So I will multiply this one, again you will get that another quantity. After this point, up to this point, if you see, one quantity is coming in positive direction, another quantity is going in negative direction, plus into minus, obviously again you will get that minus quantity, the minus of product. So this is the power again coming. And similarly if you do here, the both are the minus, so minus into minus, the product of the two minus quantities, if you do, then it is the positive value you will get. So this is the instantaneous power waveform you are getting. So this is the instantaneous power waveform you are getting. So this is sometimes it is getting the negative value, sometimes it is getting the positive value, sometimes getting negative value, and this is sometimes we are getting the positive value. So this is what the instantaneous power. So what we could understand here is, so I will derive this instantaneous power mathematically. So I try to derive this one. So P is equal to, I know this is nothing but Vm sin omega t and Im sin omega t minus P by 2 I can write. So P is equal to, again you can write some Vm and Im sin omega t and cos omega t I'm writing. So I'm again taking the minus, so I'm converting this into again cos omega t. So this is finally P, we are getting minus Vm Im by 2 into sin 2 omega t. So this is what we are getting. So what is the information we are getting from here is, so here my instantaneous power is double the frequency. It means that the frequency of this instantaneous power, is twice the fundamental frequency. It means here you can see, if you observe here, suppose my fundamental voltage sine wave, it is only completing the half cycle. Within this half cycle, my instantaneous power has completing one cycle. Suppose if you take a complete cycle of the sinusoidal waveform of this voltage or current waveforms, but in this one cycle my instantaneous power is complete the two cycles. That is called the double the frequency. So here one more point what we observed here is, the points we observed here is, so for the quarter cycle, for this quarter cycle, so this is called a 1/4 cycle of the instantaneous power, and this is another cycle of the instantaneous power. So for every quarter cycle, for every quarter cycle, the instantaneous power, this instantaneous power changes from one direction to another direction, one direction to another direction. It means that so whenever here you can say that, so in the first quarter cycle, it is coming in negative direction, in the another quarter cycle it is going in the positive direction. It means your inductors, so for one quarter cycle the inductors takes the energy, and another quarter cycle the inductors returns the energy, or it will supply the energy. So that is the meaning. So for one quarter cycle, it takes the power, for another quarter cycle, it is returns the power, or supply the power to back to the circuit. So that is the meaning of this. So therefore I can say that if you want to calculate the average power of this particular instantaneous power, because for one cycle it is going negative, for another cycle it is getting the positive. If you calculate the what is the average power for this particular circuit, then I can say the average power is 0. The average power is 0. Shall we see whether we are average power is 0, whether we are getting this average power is 0 or not? That is we are going to see here. So that's by taking the mathematical concept, if you able to prove that, then we can come to know that. So by taking the pure inductor, my power consumed by the inductor may be 0. So that conclusion I can come. So let us calculate the average power. Let us take and calculate the average power. As we know, to calculate that average power, so it is a double the frequency. So I am taking the 2 pi as a period, and 0 to 2 pi, and this is my instantaneous power into d some omega t. So I can say 2 pi and this 0 to 2 pi. Instead of this instantaneous power, I can substitute to this equation here. I can substitute, so Vm Im by 2 I can say, so minus sine 2 omega t into d omega t. So this I can read. Now if you simplify this integration, and substitute this value, so this is going to come 0. So I can say the average power is 0. So that is the thing we have to need. So you write the what are the observation you have gone through this network when we are connecting a pure inductor to the AC circuit. So what the conclusion we have got is that, so the power observation, the average power is 0, the first point. So the power consumed by this average power is 0. It means the power consumed by, or power consumption by the inductor is 0. Because for one quarter cycle inductor absorbs the energy, for another quarter cycle inductor returns the energy. It is takes the energy and returns the energy. So for finally the average power will consumed by the inductor is 0. So that is the first point we need to understand. The second point is, so whenever this pure inductive circuit has connected to the AC system, then here voltage and current, so always your current lags voltage by 90 degrees. So your current lags voltage by 90 degrees. So this is also another point we have to understand, we have to remember here. Now we will take one numerical and we'll solve this theoretical part, so that some concept, some more concept may be clear for us. So I will take this one now, and a 0.014 henries the choke coil is the choke coil with negligible resistance is connected to a 220 volts 50 hertz supply. Then determine the first point is given is how to determine the inductive reactance. The second point is we have to do the current flowing through the coil, The third point is how to determine is the power consumed by circuit. And the fourth point we have to do is maximum energy stored by the coil. So this is the numerical has been given for us to calculate, to understand the theoretical part. So let us take whenever you have going for the solution, first you have to take the description of the solution into a diagram. So this is very simple. Choke coil is given and they are saying that this is my voltage. So for this inductor is 0.014 henries is given, and this is the 220 volts and 50 hertz also is given to us. The first thing what they are asking is they are asking to find inductive reactance. What is this? Nothing but WL, or you can say 2 pi FL. So 2 pi into what is the F? Frequency 50 into what is the inductor? 0.014. If you do this one, you are going to get 4.4 ohms. The second point is they are asking to find what is the current flowing through, what is the current I is flowing through this inductor. So this I can write, this is nothing but V by XL. I can write XL because this is inductive reactant. So this is V is nothing but VRMS, so 220 volts by XL is 4.4. If you take, this is the 50 amperes. The third point is they are asking to what is the power consumption. So what is the power consumption? The P average, the power consumption by the pure inductor is 0. So this is the answer for the third question. And the final question is the maximum energy absorbed by the inductor. So in general, the energy absorbed by the inductor, the formula you can derive is half into L into I square. So this is the formula we have for to store the energy of an inductor. So this is there, but they are asking to find what is the maximum energy is flowing is stored by this. So what the maximum energy stored is nothing but half into L into that maximum current. So I can write 1 by 2 here. It is nothing but L is 0.014, and I max I can write because I already know I. So I max I can get from root 2 into I. If you do this one, I will get. So I can write this is root 2 into what is I here? It is 50 you are getting. So you do this one, you will get the energy in joules. So this is how you can solve the equation. Now what is the note? You take one note here. So note is, we know that we know that always inductor stores the energy in the form of magnetic field. So this is one of the point you need to remember this one. So inductor will always stores the energy in the form of this magnetic energy. So this is what the you can talk different theoretical parts and calculations. So with this, I hope you may have understood this concept in well manner, and today we end this session for up to this.